What is up, boys and girls? Welcome to the next lesson of our microservice stack, and today we're going to continue, right? So basically, I think we were in data receiver, correct me if I'm wrong. So, no, data receiver, we were actually in this service, and that's going to be in distance calculator, yes. So basically, the first thing I want to fix is this calculator service, these points, right? Because what we are doing right now is basically appending these points at the time. We don't need that. What we're going to do is we're going to make a pref point, I think. Pref point, there's going to be a slice of float. 64 is basically x and y coordinates right here, so we don't need this actually. Yeah, it's fine. So what we're gonna do is each time we're gonna calculate the distance, we're gonna say that that's a good question. How can we see that the pref point is being set? That's a good question actually. What we could do, actually, to be honest, maybe we should make it a coordinate or something. Nah, it doesn't matter. We could do something like this. We're gonna say if s pref point. Wait, actually, we could check that. We could check this, right? We could do a little trick. We could say s pref point like that. Pref point, if that's bigger than 0, it basically means we already set 1, and that's the thing we need. So if this is bigger, if we set this already, it basically means that we received our first coordinates or first data. We're going to say distance is going to be calculated distance, pref point. Is this true? Pref point. This cannot be. As points, we're going to append this. Yes. There's going to be a lot. I'm confused, but hey, it doesn't matter. You're going to say there's going to be a float 64, and we're going to say this is going to be the data lots and the data long, right? That's going to be it. The question is going to work. I don't know. I think I made a little mistake, but it's fine. So we're going to start make calculator. I think calculator. Let's do that. That's fine. He's probably Kafka is basically working out for some reason. Is that true? Confluence Zookeeper is up. Console is up, but that's KB. Yeah, that's from my job. Wait. Docker Compose down. Let me see what's going on here. Let's stop everything. Let's restart. Docker Compose. Compose up. Shit, we are doing this. This is so bad. I need to do -d. I think maybe Docker Compose up -d. I think the problem could be, let me open up my maybe it's Kafka is already used or something, and then we are broken. Let me see what's going on. Zookeeper is running, Broker is running, everything is running actually, to be honest. So that should actually work. Yeah, make calculator. It should actually work. Calculator. Let's see. Oh yeah, Kafka transport started. All fine. A restart was what we need. We're gonna say make receiver. Boom. And then here we're gonna say make OBU. OBU. Boom. Let's see what's going on here. And on topic of partition, it's fine. It's basically it's using an auto topic creation, right? Now we're creating these distances, so now it's actually working pretty fine, right? Cool. And now we don't have the problem of appending all these points, which can cause us some issues in the future. So what I think we're gonna do, let's open up OBU real quick, because I think we are sending it a little bit too fast to for our development process. Because we're gonna do some login, and if it's going to the speed of light, it's just annoying. Our terminal will be cluttered with all that shenanigans. Where do we send that stuff? Send interval here, it's fine. Let me see where I set this thing. GD, boom, we are here. Time second. Let's do time second times, I don't know, every 5 seconds should be fine, right? Let me see. This thing is running. Let's kill it and let's kill that. All right. So the next thing we're going to do basically is let's open up this service thing. Let me open up actually this calculator. So what we have the service. Let me see if you guys can see this perfectly, right? Yes, you can. So we have the service, we have the main goal, we have the consumer. But what I want to do here is it's going to be calculate distance. I want to wrap this again with some login middleware. That's a pattern we always going to use. We're going to say let's call this just middleware because we're going to add some other stuff in it. Then we're going to say type. First the package maybe. We're going to be package main type log middleware. And that's going to be a structure, right? That's fine. Actually, we need to do the same shenanigans, right? So we're going to say next here, which is going to be, do we have a producer? How is our, is an interface here? Yes, calculator service. Yeah? The next is going to be a calculator servicer, just like that. Did we already do this? Something that I, distance calculator, let me see. No, we didn't, right? So what we're going to do is we're going to make this, let's kill these screens here, by the way. We're going to make this a next calculator servicer. We're going to say func new log middleware. That's going to return us a calculator service, right? No, servicer, right? And we're going to say return. And we need the next, of course. So that's going to be next. That's going to be a calculator servicer. Return log middleware. No, that's not the case. We're going to say return middleware, log middleware. And type it out because VS Code will basically type in wrong stuff sometimes, right? And we're going to say next, it's going to be next here. Boom. Boom. Of course, it's going to fail out here because we don't implement the calculator servicer. And what do we need to do? Func. We're going to say middleware, M. It's going to be the log middleware. Going to be calculate distance. Calculate distance. That's going to be the data. It's going to be data. OBU types OBU data, basically, I think. OBU data is perfectly fine. And we're going to return, I think it's going to return a float 64 and an error. It's just like this. But what we're going to do, basically, I'm going to show you another little trick here. What's going on? Let's return nil nil for the compiler. Nil nil. Boom. What's going on here, right? Next. Do we implement a wrong thingy? Do we implement the wrong thingy? Types OBU data, yada, that's all fine. Middleware, what's going on? Other middleware, distance, calculator, boom. Oh yeah, a pointer, of course. Yes, let's take the reference, right? So that's that, nil, we can't, 0.0 is perfectly fine. So what we're gonna do here is we're gonna basically return named arguments, right? So we're gonna say the distance, maybe. Dist, let's call it dist. This is a float, and the R is going to be an error. Why do we do this? Well, I'm going to show you, right? So we're going to say defer func, right? Just like this, and we're going to say logres log info with fields. I want to do with fields. With fields, it's going to be logres dot fields here. I'm going to say info here. We don't need anything probably. And then here in these fields, we're going to say, first of all, took, which is going to be, again, our trick here. What did we do here? Time. It's going to be, I think, start, time. And then we're going to say here, time now. And then we're going to say time since start, right? Beautiful. Then we're going to say error. If there is one, it's going to be this error, right? You see, that's why we do these named arguments, because we're going to say that each time before the function returns, we're going to log out this error. If there was an error, right? If there is no error, it's going to be null. It's perfectly fine. So then we can see in our logs, no error. But at a certain point of time, it's going to give an error. We can directly filter it in our logs, and we see the error. Muy bien. So what we also want to see is the distance, actually. We're going to log out the distance here, which is going to be dist. Do we need something else? I don't think so. We could say, for example, request could be calculate distance or something, but that's something you need to know if you want to do that. Or maybe here, calculate distance, right? Something like that. right, so, and then what we're going to do basically actually is just return m next, right? And then, no, m next, calculate distance with the data. And wait, we need to do this. Don't think it's going to work. Let me try this real quick. I don't think this is going to basically capture these values. I think we need to do something like dist r. Yeah, dist r is this, right? And then just return here, right? That's what we are going to do. That's the play, right? So now in our calculator main, we're going to say the service is going to be a new calculator service. And then we're going to say the service is going to be a new log middleware. And we're going to provide this other the service inside of that. And then we're going to put in the service in our new Kafka consumer. Yes. So what we're going to do is make calculator. Boom. We're going to make the receiver, of course. And then, of course, hey, it could be interesting that we make some kind of a makefile that basically boots everything up. That would actually be even better. We're going to do that later on. Make OBU, right? Boom, just like that. So now we could see perfectly here. Look at this. Every 5 seconds, it's going to, you see, print out the distance here, which is that. The error is nil, which is fine. Took 400 nanoseconds. All good to calculate that stuff, right? Of course, we print out also distance. Where do we do that? Probably in service somewhere. Do we print that stuff out? That's the question. Oh, sorry guys, I was distracted by something real crazy. Do we print something out? Distance here, look at that. Where do we print that? FMT? Nowhere to be found. I'm thinking, where do we actually print this shenanigans? This is the mad squirt. Service. Oh, I know where it is. It's probably in consumer. Somewhere. Here is the distance, right? Yes. Okay, cool. So this is our distance here. Yeah. Let's do this real quick. Underscore is distance. All right. So basically what we're going to do is each time we have this distance, our service is basically set up. We have already a logging middleware. We could do other Prometheus later on. But I want to make the global scope of the thing working, right? The global setup. The next thing we need to make is the invoicer. Because that's going to be a little... It's going to be a little bigger as normal. Because the invoicer will do a couple stuff. It will also request another service. But it will also... return data to respond data to our gateway later on, right? So I think, do we need to do something else here before we go into make that other service? I don't think so. I think we're good here. I'm going to do is I'm going to close all editors. And is it actually still? Yeah, it's going. It's fine. It's basically running in the background. Why not? So we have the distance calculator, the data receiver, and the OBU. The next thing we're going to make is a new folder, and it's going to be the invoicer. Invoicer. Is that invoice? Search. Yeah, it's fine. Invoicer is fine. Let's make a new file. Main.go package. Main. All right. What are we going to do with this? Actually, to be honest, let's make a func main here so we can actually test. What's going on here? Package main. That's not what we want. Let's do an FMT, println. We're going to say this is working fine. Open up our make file. And then we're going to make another service. Look at that. Making services like breakfast. Invoicer. Go build calculator invoicer. Yeah, distance calculator. That's not true. It's going to be /invoicer. And go build. That's fine. That's fine. And then here we're going to say invoicer, right? Invoicer. Yes. Make. Let's kill everything. Make invoicer. Little dyslexic typing here. And nothing to be done for invoicer. That's completely true. Let's do it again. Is up to date. That's basically again a phony here. Can we do invoicer? And phony, yeah, I don't know, guys. I'm not a makefile expert. The only thing I know, I'm going to be completely honest with you guys here. The only thing I know about phony is that I'm using that for when it's basically not updating my makefile. If it tells you that there is nothing to be built for invoicer, no updates or something, put it in the phony and you're Gucci. You know, it is what it is. Sometimes I don't go deeper. Why it is, right? This is working fine. Cool. Main. So invoicer main. This is going to be a little bit interesting, right? Because this invoicer is going to have a transport. It's going to have, how are we going to reach this invoicer? That's something we need to think about. Are we going to use JSON or are we going to use something else like proto buffers? Well, we are going to use both, right? And I'm going to tell you why. So basically, you need to set up your microservice transport independent, which what we actually already do, right? But this invoicer is going to be the perfect example for that, because we first going to start off very simple, and that's going to be JSON, because that's what companies do. Most of the time, they're going to start off very simple in JSON because it's easier to debug. Nobody needs a third-party library. Everybody can parse JSON like it's basically just another day in the park, right? Another walk in the park, another simple day. And once everything is set up, we can add another transport, and that's going to be the proto buffers, because I think I'm going to teach you proto buffers. Maybe you already used it in another language, but I'm going to teach you it here in Go, because proto buffers is going to get used a lot, right? It's proto buffers message pack, which is, if you know proto buffers, you can basically implement anything you want, because all right. So what we're going to do, we're going to make this invoicer clean. We're going to say service here .go package main, right? Let's kill this, and we're going to say type. We could actually call this invoicer. Why not? It's a beautiful interface name. Interface. Actually, to be honest, what are we going to do? How are we going to name our interface? I didn't think about that, actually, to be honest. Like I said, I'm building this out of the top of my head. I think what we need to do is we have our distance calculator is calculating the distance. Then it's basically going to send that to the invoicer, right? What we could do is make a method here. We could say handle distance, but that's weird. We could say receive distance. We're gonna receive distance, or basically calculate invoice. That's maybe better. Is it gonna respond? Probably not. Maybe we're gonna start with that. Calculate invoice based on, of course, again, types OBU data. No, that's not true. Actually, we didn't have any spec setup, guys. We didn't have any spec setup what the distance the calculator is going to send us. But I think that's going to be invoicer specific. Calculate invoice, I don't think that's going to be it. That's going to be for the invoice calculator, which is going to be another service. I know. This is an important aspect, because sometimes you're going to think about some stuff, right? And it's easy to overthink stuff. So we're going to quickly come up with something. The invoice is going to receive data from the distance calculator. It's going to calculate the distance, and then it's going to send to the invoicer, which is basically going to aggregate these distances. And each time we request to calculate, we could do this. Aggregate distance. Based on, now we need to come up with a type, right? Do we have types here? Yes, here we're going to make a new type. And we're going to call this, can you see this? Yes, you can. We're going to call this type, let me quickly think. we could call it distance, but that's we could call it distance because there's going to be a structure and we're going to have a distance. Because that's how it worked in the real world. Also, there was some kind of an aggregator. It was not an invoice, it was an aggregator. And that thing just which basically just aggregated distances. So maybe we should actually rename this invoicer to aggregator. That's a thing, right? And then call an invoice calculator, which could calculate based on this aggregated data. Because this is going to be distance. That's going to be a distance itself, which is weird. Maybe we could call it value, so it's going to be a slice of float 64, right? The lot and longs. No, it's not true. It's going to be, this is the distance value. And then we're going to say it's going to have an OBU ID, right? Which is going to be an integer, in my opinion. Let's call this JSON value. Very important, guys. This thinking process is very, very, very important. And we're going to call this OBU ID, which we already have, just like that, right? It's fine. So we're going to receive, actually, to be honest, maybe we want a Unix actually here, right? It's going to be an N64, which is going to be the timestamp when we received that thingy. It's very important, I think. You could call it a timestamp or a Unix. Where I work right now, in the place where I work Trading Light, we use Unix as a value, as a field name for that, right? Not timestamp, you just use Unix because it's going to be a Unix timestamp. So everybody's going to know it's going to be a Unix timestamp. Very important. So it's going to be the distance, right? I think that's clear. So we're going to aggregate a distance, which basically means we're going to receive this distance. That's fine. It's going to be a types distance, of course, right? Types distance here. And we are going to return maybe just an error, right? Nothing going to do here. Nothing extra in this invoicer. Maybe we should call this the invoice. I'm going to call this aggregator. Aggregator. That's going to be an interface. Now we're going to say aggregate distance. That is already clean. Because basically that's going to aggregate that. Okay, I think I have a good idea. The question rather is if this service name is going to be the invoicer. What I'm gonna do. Copy VS Code link. This is hard, guys. This is hard. I'm trying to be. So we're gonna receive this data. We're gonna aggregate this data. We're gonna save this data somewhere. And then at the end of the day, we're going to, yes, this is going to be the aggregator because this yes, I have the best idea. It suddenly came up, right? Like I said, guys, you need to iterate. Don't be afraid to change names. Don't be afraid to swap it out. This is going to be the aggregator. Aggregator. Boom. It's already been taken care of. Look at that. It's the aggregator. And the aggregator is just going to aggregate distances it will receive. That's what it's going to do, right? Aggregate distance, perfectly fine. We're going to make an implementation here. We're going to say invoice aggregator. That's going to be a structure here, right? That's fine here. We're going to say func. I'm going to call it A from invoice aggregator, or maybe Y. Invoice aggregator. We're going to say aggregate distance. And that's going to be a types, so types distance. Actually, to be honest, I need to do data or dist. Distance is fine. It's going to be a types distance, right? And it's going to return an error here, just like that. And what I'm going to do real quick is delete this screen and this screen. And let's return a null here real quick, right? So that's what we're going to have. That's perfectly fine. Aggregate distance. Okay, so what we're gonna do here, maybe we should actually do a store, and that's going to be a storage, right? So we can make another interface, for example, storage interface. We're gonna call this a put insert, maybe something simple, which is going to be, we could put distance, a type distance. It can insert directly this thing, why not? Type distance, types distance, by the way, types distance, and we're gonna return an error here because that's a good practice. So we have a storage as an interface, insert, perfectly fine. We have a storer here, and then we could actually say something like logging stuff out later on. We're gonna call e-store.insert this distance, because most of the time, guys, there is not really for now we don't do a lot of business logic, right? This is simple, but because this course, this chapter of microservices is not about business logic, right? I mean, hey, this is about how to build these systems and how to let them communicate with each other, right? That's what we're gonna do. It's most of the infrastructure. It's the shell. It's the shells. How do you say that? The skin of the onions we are making, right? Because what you could do is you could do some double checks here, right? We're gonna see if we can do something. We're gonna say if r is gonna be if r. To be honest, I can just return here I store insert distance. Just like that. For now, it's gonna work perfectly fine, right? Maybe we're gonna do a little printing here real quick. Insert in. Wait, we could say something like processing and insert in distance in the storage, something like that, right? And what you could do is basically do something like that and say distance, right? So we can see what's being sent. And of course, later on, we're going to use logging shenanigans to make it better, just like we did before, right? What we need to do is make this func new invoice aggregator, and we're going to take in a store, which is going to be a storage. And that's going to return us an invoice. Aggregator could return an error also, but for the sake of, we're going to do that. Return invoice aggregator, and we are going to say that the store is going to be the store, right? Classic stuff we already teached. And of course, I forget. I'm not pointer heavy in this microservice stuff. Normally, I'm using pointers a lot, but now we are just keeping it. We're keeping it simple, but that's why I forget taking the reference here. All right, so now in main, this calculator is going to be the aggregator. That's something, a min point I think on VS Code is searching stuff, but hey. So what we could do. First of all, we're going to make a transport, right? That's the first thing we're going to do. And we're going to start with our JSON transport. So what do we need? Very simple. We're going to say HTTP handle func probably. Handle func. How are you going to post this? Probably a post request here to aggregate, maybe to ag /ag. It's fine by me. Or maybe aggregate if you want to aggregate, something like this, right? Yeah, and that's going to be a handle aggregate or something. Handle aggregate, which is going to be probably a handler or something. We need to think about that real quick. Let's first start our service. We're going to say var, right? SVC, just the same concept. It's going to be a new. What's going on here? I don't see anything. All right. Service aggregator. A new invoice aggregator. Why is it not working? New invoice aggregator. We need a store, which we don't have. So we're going to say store is going to be new memory store. I'm going to make something in memory just like that. We don't have memory store, so what we could do is basically do this. Make a new file here. We're going to make this store go. Package main real quick. Say type. What's going on here? Stop. Am I capsed? Nope. Delete this. Can you see this? Yes, you can. We're going to say memory store. Real quick. It's going to be a structure. We're going to finish everything. We're going to just try to make these things work. We're going to say implement the store function. You're going to say sm memory store. It's going to be insert d from types distance and error. I'm going to say here return null here. Boom. So that's fine. Memory store. So now we need a store here. New invoice aggregator is not being found probably. Oh yeah, we can because this is FCC. Yeah, it's fine. That's maybe the problem. New memory store. That doesn't work. Let's make that func. New memory store. Memory store. This is a little bootstrapping, guys, isn't it? And memory store just like that. That's fine. Of course, we're going to make it a map and yada 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 so it can work. And now we're going to have the store here. SVC is here. That's perfectly fine. So what we're going to do, we could make something very simple, right? Look at this handle. I'm going to show you a couple things. Handle aggregate. Aggregate, because it's just, this is going to be just a transport, right? Doesn't really matter. So we're going to say handle aggregate. Let's take in the SVC, which is going to be an aggregator. Yeah, that's fine. Wait, it's going to be because you cannot attach the HTTP transport to the invoice aggregator interface. That's something you cannot do. That's BS. That's no. We could do something like an HTTP handle func, which is going to return here, return func WHTTP response writer, or pointer to HTTP request. Yes, do this, and then save this. This is not going to be a handler func, it's going to be a handler func. Yes, that's what we need. And then we could say here SVC. We need to basically marshal that stuff, right? But that's fine. So we're going to say here handle func, handle aggregate, pass in our SVC into this thing. You see, working perfectly fine. Decorator pattern. Then we need to aggregate that. So that's basically we're going to say var distance. Distance is going to be a types distance. If r is going to be JSON new decoder, and it's going to be the r.body decode me the request into this distance I just beautifully laid out, and if the error is not null, I'm going to return. Actually, we cannot return here because we don't have our beautiful echo or fiber, and we're not going to use fiber because there's small services. There is no need to bring all these dependencies into the scope of this thing, right? So it's going to be this, and if there is an error, what I'm going to do real quick, I'm just going to panic out. Or you could do, for example, you can return here and then say W write. You could do a write header, for example. What's going on here? Write header, which is going to be an integer. It's going to be the status, which is going to be an HTTP status bad request. This is how we're going to do it with our bare hands. And then you could actually also write JSON if you really want. But we're not going to do that. We're just going to write status batch request. We will fix it. I will teach you how to customly write JSON to the thing. So far are we? 34 minutes. That's fine. Let's get this really quick up. So now we need to say HTTP dot listen and serve, right? There's going to be a port. Let's make quickly this. We're going to say the listen adder is going to be, let's make it like that. A listen adder is a flag string. We're going to say listen adder. Default value is going to be, I don't know, 3000. And then there's going to be some info. The listen address of the service of the HTTP transport handler server. Just like that. And then we're going to say flag parse, so we can parse these things, right? Then we have a listen address here. So what we could do now is basically do this. We're going to dereference this listen address. Very important, because it's going to be, we need to dereference it. And then we're going to say no. Boom. So what? Boom. So what's going to happen is this not going to work. Flag string, listen and serve, this is not going to work. Why is that? Undefined. Oh yeah, that's true. That's because I need to do this, right? Cool. Right, so now we're going to have a default HTTP service running at port 3000, and if we really want, we can adjust it by providing it the flag, the dash listen adder, just like that, right? Listen adder, right? If you pass that, then you could give it a port we want, right? But for now, 3000 is fine. That's all good. Can we actually do make invoice? Actually, there should be aggregator, right? We need to change that. Directory not found. Yeah, that's true, because our make file is completely borked. So we're going to call this ag from aggregator, and it's going to be aggregator, and it's going to be ag. Let's short it down. So we're going to say make ag 2 G's, boom, GG, of course. And then you see server is running. So we could actually open up our main aggregator. Yeah. We could do something like, make a function here, make HTTP transport, because we're going to make another transport also. Make HTTP transports. Let's give it a listen adder. It's going to be a string and maybe a service, actually. It's going to be an aggregator. We're not going to do anything here. The only thing we're going to do is listen and serve, take this, copy, delete that, by the way, actually, to be honest, because we're going to paste it in here. That's going to be the listen address here. And then we're going to say fmt println. We're going to say HTTP transport running on port. That's going to be listen address. Boom, just like that. All fine. I'm getting a little phone call here. I need to help telling people that I'm busy. It's annoying. The problem is I'm doing a lot of recordings every single hour of the day, and it's now like people are just done with working, so they think they can bother me, but that's not the case because I'm busy. A listen address is here. What's going on here? A new invoice aggregator. What's going on here, man? New invoice aggregator. That's going to be a store. We don't need that. SVC is fine. Where is our SVC going, actually, to be honest? Oh, yeah. We need to pass it in. We're going to say make HTTP transport. Just like that. And we're going to put in the listen address. No, it's going to be the store, to be honest. No, the SVC. Boom, boom. Wait, what's going on here? Make HTTP transport, a listen adder, and the aggregator. It's a reverse. And the service. Boom. So now we're going to have, boom, or make HTTP transport here, right? And then we can make other transports. You could make Kafka transport. We're not going to do Kafka here. We're going to do the make HTTP transport and a gRPC transport. That's what we're going to do later. gRPC. I'm going to teach you that. Right here, right now. Not right now, but in this chapter. Yeah. Let's see if it's going to work. Make ag. HTTP transport running on port 3000. Okay, cool. So I'm going to leave it like this, and in the next episode, we are going to do the rest. See you. Cheers.